Good afternoon, evening, and morning, everyone, and welcome to our webinar. My name is Martin McGloin, and I'm streaming to you live from my home office here in sunny Oslo, Norway.
Hey Martin, and hello everybody. My name is Tommy Hagenes, and I'm streaming live from my home office here in not so sunny Bergen, west coast of Norway. And we are really delighted to see so many people join us for the webinar today. Me and Martin had our own first webinar last week in Norwegian, and we are really looking forward to reach a wider audience today in English. So Martin, you have maybe not that normal background into the building industry. Could you please introduce yourself?
Yeah, so I probably don't have a similar background as most of you listening to us today. I don't have a building automation, HVAC, or property development background, but come from the software development world. But I think there's some really exciting synergies happening where the methodologies and approaches that you've seen in cloud computing and software development coming into how we think about technology and optimizing our buildings. So I think it's a very exciting space to be working these days. So in that context, I would consider myself a bit of a nerd when it comes to all things APIs, meshing up systems, and getting both the new and the old technology to speak with each other, sometimes in a bit of an unconventional way.
So I think that the way that you are an API nerd, I might be a PropTech nerd, and even though my background is more into the BMS industry. So my previous background is more with BMS with companies like Tridium, Honeywell, Johnson, and I went over to the building side of the world to learn how to be a customer and end user, and ended up with PropTech and sensors. And what I really like with that is that I met people like you, Martin, smart people with really curiosity into the industry, and we do have buildings that are full of data, so we really need the new faces into the industry.
And I think the reality is, Tommy, is that we're seeing more and more data coming out of our buildings, which creates a bit of challenges, but also opportunities. But it's not only the commercial buildings it's related to, but also on the residential side. And I think a great opportunity we also need to look at is that there is a lot of things happening at people's homes. And I have been home to your place in Bergen, and I know it's chock full of sensors and IoT devices in every room. And I think you even, I don't know if you're scared to admit it, but you reached a bit of a personal milestone, shall we say, recently?
Yeah, it's some, I don't think it's something to be proud of, but I reached more than 1,000 sensors. So I think it's officially diagnosed, and I can't see any return on my investment anymore.
But I think the fact that you have all of this at home and you have it as a hobby as well shows that we have a passion and curiosity for the field that we're working with about how do we get to know our buildings better and how can we use this data in a positive way. So hopefully we can let that shine through in our webinar today. Okay, I see there's still people joining, and I'm excited to actually see so many joining us today and showing some interest in our topic. Let's give people a bit more chance to download plugins, connect their headphones, and get comfortable. And maybe let's talk through the agenda, Tommy. You'll kick us off today with a bit of a painful truth that we observed in Norway about our buildings. And the reality is that we don't really have control of them, do we?
So that's kind of the sad truth that we have seen, and that everything is shutting down, yet the energy consumption remains the same. And this is something that we saw in Norway, but we also talked to a lot of friends of us out in different countries, and we saw the same pattern there. And that's also why we wanted to talk about this. So what we are seeing is that the building is shutting down, but it keeps humming out like nothing happened. So that's what I'm going to talk about. And you're also going to go into energy, Martin, but maybe more of a niche topic concerning radon. Could you please
I will focus on radon gas detection and mitigation in public buildings. But really what I think there's a general lesson specifically, and that is about how do we use sensors and technology to ensure an optimal balance about a healthy and productive indoor air environment, but at the same time, we can use the insights to optimize and keep a balance with energy optimization as well. So hopefully, even though it's a niche, but also a niche that everyone that operates and manages buildings, both commercial, public, and private, need to take into account.
Yeah, and after that, we also gonna share our experience when we traveled together, where we took the pulse on HVAC, air quality, building certification around the world, and we also have Antoinette behind the WebEx system today that will also answer technical questions with how to log in and stuff like that. If you have any problems, and she will also be gathering all of the questions, and we hope to have a few minutes at the end to answer all of your questions. But I think with that said, Martin, I see people are logged in, so I think we need to start.
Right, okay, but hold your horses a little bit, Tommy. I think there's one important thing that we should mention before you get going, and that is that we're running a little competition today. So those of you that find what we're doing really interesting and valuable and relevant to what you're working with, and stay with us to the very end, we will be drawing one attendee towards the end of our presentation who will win a complete set of wireless indoor air quality sensors sponsored by Airthings. Yeah. So keep on there, and we'll announce the winner later today. So with that said, Tommy, the stage is yours. Start the show, please.
Thank you, Martin. So as you can see in our video, the home office has become dominant these days. And we know that schools and kindergarten and gyms, and the list is long, of closed industries. And this again makes empty buildings. And in a time like these, I think many industries must turn every penny and consider layoffs. And several also expecting uncertainty about existence of some of the companies when we are about to reopen for business. And we have, in a sense, been subject for a test for our buildings. We know that the buildings go as normal, even though it's Easter, a long weekend, 4th of July, planning days, and so on. But now it becomes extra obvious during the corona crisis. And it's been a hard period lately, but I think it can also be opportunity for us. We are forced into using new technology. We are digitalizing in a much faster way. We never had a webinar before. And remote monitoring is also more important than ever. This picture here is from the early energy data of Norway. And since we know that schools, institute and kindergarten was closed down on the 13th of March, and extremely many went into home office at that time as well, we should not have seen the same curves. But we did. So power consumption in Norway remains steady, although a number of companies has been shut down due to the coronavirus. So this graph is something that we should really be ashamed of. And I think that we really need to learn of it. So regarding that, I wrote an article for one of the biggest newspapers in Norway, which was a bit of controversial and heavily debated. But it was also a big motivation for us to have this webinar to talk about it. And we did also translate this in the Airthings blog. So if you want to take a closer look afterwards, Antoinette will also fill in the link in the question mark on the webinar. So after so hard facts, I think there is also a few more facts we need to look at before we start. And that is concerning the buildings. We know that the buildings are a major contributor globally to high consumption and high CO2 emissions. And we know that 80% of the building in 2050 are already built. So, and we cannot demolish, so rehabilitation is the solution. And therefore, it's extremely important to think about existing buildings. We also had a very interesting study in Norway in 2018 regarding buildings. And we found out that 10 out of 10 buildings had issues with the building management system. That's also why we need to start new technology and get more insight. So that brings me into my purpose in my career. And that is that we know that there are so many buildings out there without any data. So in other words, this means that a lot of building depends on people to be present to have control. So when no one is there, it's like driving a car completely blinded. So with all the sad facts that we have, let's take a look at what we can do with our buildings today and learn from this big test that we have been through. And if you have data in your building management system or energy optimizing system, it's exactly the same principles. So if you don't have anything, I will also talk about how easy it is to get data. And maybe the end solution is also we need to combine both solutions. So I don't know if this is something for other countries as well, but in Norway, we used to have this in the kitchen. And it gave us an insight about the consumption we use for energy. And it gave us real-time insight. And with this insight, we could easily turn on the boiler, turn off the coffee, make sure that we use the power the right way. And for me, I really believe that we need to have insight. We need to have fact when we are controlling buildings. And this meter is now taking steps to the next level and being digitalized to come to life in the new smart grid. And this is something that I think is very exciting. And so when I show things like this, I always like to say, who has this? Because that's what you do in a seminar, but in a webinar, that's a bit harder. So I will try to talk about the cool possibilities instead. So European Union aims to replace at least 80% of all electrical meter with a smart meter by 2020. So this year, for all of the European countries. And in Norway, we already completed this last year. So that means that we have smart meters in every building. It doesn't matter about the size. And smart meters give us real-time insight into our energy usage in all buildings. But again, a sad fact, we hardly use it. We have all of this free open data, but we don't use it. So getting data here is quite simple actually. You can build it yourself, you can find a project on GitHub, and it will just cost you a few dollars to buy some cheap electronics for that. Or you can of course buy a professional solution from other suppliers, as a Norwegian company called Hark. And this is just a start. Today we have all the data also available on the server side, so we have not yet seen the possibilities. Just imagine how we can adjust and control the grid. So this device, so this meter gives us the ability to extract energy data every second. So we can retrieve everything that you expect to have from a smart meter, such as power, kilowatt hour, and so on. And it can look like something like this. So this is a picture from our living lab in Bergen called PropTech Bergen. And here we do test all of the real estate equipment together with all of the different vendors. And this is the solution where we put Hark solution into Grafana. And we have been using this for the last half year. And this also gives us so much insight when we are doing modification with indoor air quality and energy. So it gives us a good picture of the building, how it's running. While at the same time, we still have all the facts when we do take actions. And what we are seeing on this picture is that we are seeing that PropTech Bergen still has the pattern that shows that the electrical heater goes on and off at night and on again at day. The ventilation system has the same pattern, and you see that on heating we have the typically day-night set point. So the reason that this building is operating as normal is because we have a doctor office, we have a dentist office, and they all have urgent patients at the moment. And for this period, it's of course much more important to have good indoor air quality so we don't contribute to even more infections. But if you had this data in all of the shutdown building, like schools, like kindergarten, the empty offices, this pattern will actually show you that the BMS system or the manual thing that you did not work. The building is still running as normal. So all buildings are operated according to a risk assessment, or they should be. So if you don't have any data, you don't have sensors, you don't have a building management system, then I would completely understand why we don't do anything. So if you have a building management system with temp and humidity, then use it. If not, it's very simple to get up sensors. And I will never recommend anybody to just turn off the building without any insight at all. Because in this period in Norway, we had snow, we have negative degrees, and it could have major consequence for the building if you just turned everything off and didn't have any insight. So what can we do with only temp and humidity? So in Norway, where it's cold, we want to use minimum energy on heating. So this is probably the same for countries that has a high temperature. You don't want to cool down your building if nobody is there. We don't want to use energy when we don't need to. But we don't want to damage the building, and we don't want to create the right climate for bad stuff like mold. So here you can see a big property developer in Norway, on Garda, who have complete control over the building and saving huge sums by lowering the temperature. And this building, there isn't any people in it now. So we actually set up the sensors when the crisis struck. And Frank, who is in charge of the building, could manually adjust while ensuring that the building does not take any damage, and also ready for the tenants when we reopen. And I think this is a good example of how easy you can just get some measurement and then you can take action. And in this building, we also shut down the ventilation system, but we're also measuring VOC, your radon, the CO2, and light, and continuously monitoring whether the ventilation system should run for a short period if the sensors indicate this. So what could we save based on this? Well, in Norway, we have this energy foundation called Enova, and they are pointing to a 5% energy reduction per degree when lowering the temperature of energy cost associated with heating. So this is the big expenses in building, also together with the ventilation system in these periods of time. So what we are doing here is that we actually are decreasing from 22 degrees to 15 and 16 degrees. And this will give us a huge save. So I talked to a lot of building owners about this, and I really understand that it's difficult to start with, because you might have a system that is outdated, you might have no system, and I just want you to encourage you to get started, regardless of what system you have, and maybe just one sensor would be enough for you to do something about the building. And I think just the one sensor principle is pretty cool, because I think the principle of a multi-sensor is very important, because it's when you combine data, you get the real value, in my mind. If we look at raw data, we get quite a lot of information from this. But for the untrained eye, maybe it doesn't add value. So I'm gonna look at how we can read the raw data and bring value into it. And just for clarification, this is a school building, and it has a BMS system, so it has a building management system, and the building is completely empty. And it's also Easter holiday for the whole week here. So it should be stopped anyway, even though we didn't have the coronavirus. And here I come back to the sad confession, and I'm going to show you why. Because we see time and time again, even though there is a building management system, well-known vacation, we still waste energy. But I really hope that because it's so obvious now, we will really learn from this period. So let's start to analyze this picture. So on top line, we are seeing the radon, and it's picked up over the weekend, and then it disappears again in the week, and then it builds up again in the weekend again. So if we are combining this data together with the TVOC pattern that we are seeing with highs and low, it gives us a very good confidence that the ventilation system goes as normal, even though it should be off. And what we also are seeing, we are seeing that the CO2 is located around 410, 435, which is the same as the outside. And that gives us a very good indication that there is no people in the building. And we already knew that because of Easter, but we also had that confirmed with the sensors. The humidity here is low, as it is this time of year. But it also gives us a good indication for higher risk from infection by viruses. But it also gives us great potential in reducing temperature without any condensation. So you're also seeing the temperature here, and it shows the same pattern as ventilation. So you see that we are saving energy in the weekend, but then we start to heat again in the week when there is nobody here in the Easter, and it's not even saving energy at night. And so this is kind of the sad truth that we are seeing, and how it should be. Actually, we should see if this was a normal week, there were people there, then we should maybe see this graph instead, where you're seeing the night mode on and off. And like Anova said, this is something that we can really save a lot of energy on. So just by one sensor, I get all of this information from the whole building. And I think that's really, really cool that we can see all of that information with just one sensor. And with that in mind, I can't understand that we're saying that 80% of the buildings are offline without any data, because we now have a way of just putting in one sensor. We have a scalable way of doing this. But I also think that some of the property companies and also us, we need to provide more value of the data. And I think what we are doing now with occupancy, I think that's a way of converting raw data into value. So what we are seeing here, that this is all our algorithms for occupancy. And you see that this is much easier to see that there are people there or not. You see how we are seeing it now, there is nobody there, and how it is on a normal school week. So just imagine that we could have all of this data and we didn't have the coronavirus. So this insight can actually help us to operate and manage the building better on normal conditions. And I think that we shouldn't just stop there. This is also data that other industries should have. So what about cleaning? What about cantina? This is so much good data that they can actually do cleaning based on where people are. If nobody is in one floor of the office that day, then we shouldn't clean there maybe. And also, if we collect all of the data for the building or buildings around it, then maybe we could also give good value data to canteens so we don't waste that much food. So every time I start to do stuff like this, I always take it too far. And I think this is a fun example of how we can use open data for just one room and get so much insight. So on our living lab, the PropTech Bergen lab, we meshed together our multi-sensor on top together with Cisco's inbuilt sensor in the meeting room. So this is our smart meeting room at PropTech Bergen. So we meshed our sensor for indoor air quality. We meshed how we are counting people, the decibel, which also gave us a massive indication of how the technical systems are going off and on, because we can actually see that. We also have disruptive technology sensor at the door, so we can see if the door is open or unlocked. And that's also a good indication of how the air quality is inside of the room. And I think the important message here that I'm trying to get further is that if you are using data from an open source, then you can combine it into open sources like this, like Grafana, and you can actually start to collect your data together. So is it only the nicest and the coolest and the newest building that deserve to have insight? Because this is insight you can easily have in any building. And if you have a meeting room system, then maybe you already have it. You just have to use it. So this is something that I think is a really cool way of doing it. I also think that it's important that whatever system you have, if you also have a building management system, we have to have open systems, because then we can share data across different platforms. So I have one last story I just want to share with you guys. And this is a story of a company from Norway, from Bergen, my hometown. So this is the renovation company in Bergen. And what they wanted to do, they wanted to put sensors for all of the trash cans that we have in the street. And the reason for that was that they wanted to find out who was not paying for the trash, because they could see that a few percent was missing. So the goal here was to put sensors on every trash can so that they can track when they was getting emptied. And they had calculated a 2.5% saving, which would be a payback for all of the sensors in just a few years. So what they experienced instead was that they suddenly had data for everything. They could relocate the entire logistics. So based on all the data, they actually reduced 20% on the cost for all of the cars and 30% reduction for all cost based on route optimization. So they installed sensors to look at one specific part, and they gathered data to realize it could be used to so much more. And I think that's like the moral of the story. You don't often see your savings right away, and often you need to just start to get the insight, and then you see all of the synergies. And just imagine today, we have so many empty buildings out there that we don't have control in. And what happens if a building today doesn't have a daily inspection? Because people are sick or they are home with kids, no tenants are there to report it. So what if it was a water leakage in the building? Would the insurance cover it? How long would it take to fix it? And would the tenant actually survive even longer without an office when we open up again? So we have been through a big test for our building, how we operate and how we manage building, and we see that buildings still run as normal. And commercial buildings has used as much energy as usual. And I think we can learn a lot from this crisis. We see that the time we have been in now, there are opportunities to save hundreds of thousands on commercial buildings, but just making the right choices now. So where we have seen return on investment for PropTech and sensors in 1 year, we actually see that in 2 weeks now. So your building can actually come stronger out of this crisis. So my urge at the end is start today. This is a continuous learning where the learning is the goal. So what you experience on such a journey is often what makes your business or building the best. So with that said, thank you very much for listening to me, and feel free to contact me after the webinar for questions beyond this. And please warmly welcome my colleague Martin McLeod. Are you there, Martin?
I am. I'm still here, Tommy. Thank you. Thank you very much. I think it's such an important lesson that you're pointing out, that we can't continue to be blind about our buildings. And I think a lot of property owners, particularly in Norway, have realized now that when they can't when people are no longer at the building, they can't even send their maintenance staff or their operating staff out to the building. They don't have any, there's very few of them that have the insights they need about the building to continue operating.
For
So
sure.
let me continue on what you've been saying. I think it's important to mention that we are going to cover quite a bit of ground today. There's some very interesting topics that we'll be talking about, and we won't have time for everything. I know we're both eager to hear if there's any ideas, inputs, thoughts, or questions. Please reach out to either Tommy or myself. And I know we'll always appreciate a connection request on LinkedIn, right, Tommy?
Yeah, for sure.
Sure. So let me continue what you were pointing at, Tommy, in your presentations and your main thesis, and be a bit more concrete and practical. And really what I'm going to talk about is energy optimizing the mitigation actions when we've identified a radon problem in a building. But in a wider sense, it's about transforming raw data, raw sensor data that we're increasingly getting in our buildings into actionable insights. So IoT for me is not really about making smart buildings, which is often the headlines we see, but these property technologies is about enabling people that operate and control our buildings to make smarter choices, to make them smarter. So going from raw data into actionable insights about helping the users make smarter choices in how they optimize and run their buildings, also to save energy. So I will demonstrate this very practically in one new product update that we're getting in Airthings. And I think that is a great illustration of how you can use the indoor air quality data to improve how you run the buildings. And it's all about fine-tuning and adapting to the changing needs of our building. A building is not something that we just program up once it's commissioned and then leave for the next 15 to 20 years. A building is a living, evolving entity that has changing needs, and we need to adapt to these needs, which is starkly becoming a realization in these days. And the sensors, they help them come to life. And the most beautiful thing I know is seeing the temperature graph of a finely tuned night control mode in a building, where the temperature goes up and up and down throughout the days of the week, and maybe plateaus a bit lower during the weekend. And you really reap the energy benefits that Tommy was talking about that Enova estimated. And that's an adaptive system that evolves into the needs of the building and really makes it come alive into a pulsating living being as it should be. And this joy is a lot more accessible today because it's the sensors and the technology that we put into our buildings that gives us eyes and ears within our built environment. I think Tommy's home is a great example of this, and how the technology we're talking about is really becoming a consumer commodity, which is also benefiting us within our buildings. It's so much easier, cheaper, more accessible to monitor more parameters within our building, getting access to more data. But then the question is, how do we go forward with this? So what I'm going to particularly talk about continuous radon gas monitoring. But the general lesson, even though it's a niche topic, the general lesson is, can IoT devices help ensure a balance between a healthy indoor environment and optimal energy usage? So this is, in one sense, the concern about indoor air quality is a modern problem, because we've had an incredible focus the last few decades on energy optimizing our buildings with dedicated energy optimization set of buildings. We're building tighter, more insulated, and running our air handlers, our air plants at optimal rates, minimizing the period and the exchange of air exchange, and even have building certifications that encourage and reward us. However, I feel that this focus has had at times maybe detrimental effect on the people within the building, the indoor environment and the indoor air quality. And the danger is that we're emitting more indoor air quality pollutants, capturing them inside and making the situation worse for the occupants. In a historical perspective, if I take the example from Norway, IAQ and in particular radon was not really a problem. The traditional Norwegian log cabin house, as we can see here, had a good deal of natural ventilation between the joints. It's only when we started building tighter, protecting us from the colder climate, that we were capturing more of the radon gas, which is a naturally occurring gas that's emitted from the ground. So it normally comes through the basement and comes through the foundations of the buildings. And it is, as we mentioned earlier, it might not be something everyone has intimate knowledge about, but that's something we do have to, as a building operator or building owner, something we do need to have a relationship to. In Norway, all schools, kindergartens, public buildings, office buildings, commercial buildings are required to do regular radon gas checks and monitoring and do actions if the levels are elevated. In the EU, there's EU-wide regulation requiring that all nation states have laws in place to ensure that no building exceeds 300 becquerel. And in the US, nearly every house transaction requires a radon inspection report. So I think you've all come across this at some point. Here we can see, I think it's very interesting, intuitive to look at the radon risk map for the US as an example. And there are similar maps for other parts of the world as well. And you can see that the red zones are predominantly in the northern part. And again, it's correlated a little bit to the colder climates because we tend to have tighter buildings and perhaps don't open up the windows for most of the year as well. This is radon gas. Or at least this is the best way we can visualize a gas that we do not have the sensors to detect. So the contrails you see in this cloud chamber, which is a high saturation point chamber, where we can see the ionization trails of alpha particles. Now, alpha particles, so it's not the radon gas itself that we're witnessing, but actually the energy being released as the radon is decaying through its, going through its radioactive decay. And this is what's also happening within the lungs of people if you breathe in radon gas. I had a bit of fun with my PowerPoint animations to illustrate this. And you can see just breathing in the radon molecules themselves is not the harmful thing. It is this decay point when energy is being released in terms of alpha particles. So if that happens, if we have a radon molecule in our lungs and it decays, it will release this, and there's a small chance that it will damage the DNA in our lung tissue. And this is how radon gas has become the biggest cause of lung cancer for non-smokers. It's estimated that about 21,000 deaths a year in the US and about 20,000 deaths in the EU can be attributed to radon gas. So something we do need to take serious and take into account, and it's one of the many pollutants or elements within indoor air quality that we as building owners should be responsible for. But let's make this a little bit wider, because I think radon is a good illustration of the importance and value of IoT and sensors within our building. As a human, we can't see, smell, touch, feel radon gas. It's completely inert, and we are dependent on technology and sensors to detect it. But that's actually true for the wider dangers within, or maybe not air in general. So for us as humans, we're not very good at detecting whether the air we're breathing is good or bad. And we are dependent on technology to augment our senses in a wider sense. If you think about CO2, it's really just the effects of it that we can notice, not the gas itself. When it comes to dust particles or PM, particularly sub PM 2.5, as we call them, so it's the ones that we can't see with the naked eyes that are the most harmful for us. The ones that are bigger and that we can actually see tend to come back out again from our lungs. So it is an illustration of the need for sensors and understanding our buildings wider. But let me put this problem in a little bit of context. So I did a mapping amongst Airthings customers to understand the extent of this problem and the associated cost. So it's not a statistical significant survey, but it gives us a bit of an indication. And there is a slight balance for the Norwegian context. But I do miss a wider survey and understanding of how this is related. So what I found is about 10% of buildings have recorded elevated radon levels above the government threshold. So in Norway, we call it the action level is at 100 becquerel per cubic. In the US, the EPA has this at 4 picocuries. So the measurement unit is different in the rest of the world and the US, but it's roughly in the same ballpark in terms of where the thresholds are. So it's not the biggest problem, but again, as I pointed out earlier, there's something that we all need to take into account as building owners and operators. Now, what's very interesting, there is a lot of technology out there to mitigate radon if you do identify elevated levels, but the most efficient go-to action that people are using is increasing the ventilation rates with using their existing air handlers. And this is also what the EPA in the US, the Environmental Protection Agency, recommends as their initial action. It's also a very sustainable action if you think about it, because we're using the existing technical plans and we're not doing additional invasive procedures. For example, we could put in radon fans. There's radon chimneys, and there's also you can put membranes down on the foundation level to try and seal off so it doesn't come through the foundation of the building. But the initial go-to action is increasing ventilation rate. And on average, what's normally done in the Norwegian context, and I've seen in other places as well, is that you just start ventilating earlier in the morning and perhaps a little bit after hours, outside of the normal operating hours of the building. In the most extreme cases, I found that they were running the ventilation system 24/7 to mitigate radon within the building. And of course, this has a cost associated with it. So on average, the estimates we did, and this is based on the Norwegian energy prices, and we do have abnormally low electricity prices than the rest of the world. So this could quickly become much higher in other parts. But we're looking at $5 to $10 per square meter per annum. So if I take a typical school here in Oslo, which is about 10,000 square meters, you're looking at $50,000, $60,000, $70,000 in additional energy costs per year, running your air handlers and heating or cooling the air that you're taking in outside to mitigate radon. So then, of course, you want to make sure that you're not overdoing this because it can be quite expensive. And then looking through this data together, I realized actually just looking at the raw sensor data that Tommy showed earlier isn't sufficient to really get the insights to make the earnings. And having done a bit of an analysis together, we've quickly identified opportunities to reduce this by 65%. So being able to think of this in a wider aspect can already give us some savings. Why are they not doing this today? And that is the big customer challenge that I'm seeing. And I think this, again, what I want to keep in mind that we're talking about, I'm speaking about radon specifically, but I think we can translate this to indoor air quality pollutants in general. And initially, it is this static control in a dynamic reality. And what does that mean? What I mean is that the building is evolving, the challenges, the realities at the building evolve throughout both the day and the year, and putting in one mitigating schedule or one ventilation schedule as a result at one point in time might not be sufficient later down the line. So often they get very defensive and over-ventilate rather than run the risk of under-ventilating and then having elevated radon levels. And I think this reality can be reflected if we look at the variation within the building of radon concentrations throughout the year. Because this can depend on geology, the weather, pressure, how we're running the building, who's in the building, etc. So there's really something that we need to take into account. It's not a static reality, but something that dynamically changes. Here we ran a study in a building over a whole year to illustrate and measure the extent of which radon concentration can vary throughout the year. And what you can see here is that depending on when you do your measurements and when you do your actions, you might be blinded to the extent, you might underestimate or overestimate the problem in your building. So very early on in the radon season, as we call it, which tends to be during winter time, that's when we tend to find the highest radon concentrations, as you can see here as well. If we did it before Christmas, you'd believe that you'd be within the Norwegian action levels, and you wouldn't have to do any mitigating actions. However, if we did a measurement late in the radon season or after Christmas, you'd get a completely different results on your measurements. So doing a short-term or point measurement is really a challenge here. And I know a lot of other, let's say, building certifications or building approaches to indoor air quality is very dependent on point measurements, which might give, it'll give you an answer at one point in time, but it very often very quickly goes out of date. This is radon POC, or this is how we measure radon traditionally in the building. And it's literally in Norwegian, I like how it's very specifically called. It's called spor film, or literally trace film, because what you see inside, I've taken off the lid of this radon POC here. This is placed in 2 months period during this radon season at the winter time when the radon concentration tends to be the highest. It's placed within the lower floors of the building for 2 months, sampling the air, then it's sent off to a laboratory and it's literally developed like a film. And that's why we call it the trace film in Norwegian. And this is what the result looks like. So all of these holes are the traces from alpha particles, which is the energy being released during the radioactive decay. And what we do is that the laboratories will count, okay, how many traces do we have? How many radon events have we captured? And then they do a calculation of the concentration over the full 2-month period based on this number. But again, it gives you a long-term average, and it might not give you the true picture, particularly when we have to take into account that we run our buildings differently throughout the day. So during working hours, if we have balanced ventilation systems, there's a lot higher degree of air exchange and air filtration going on than outside of working hours. So often what you follow up with is an electronic measurement that gives you hourly averages throughout the day. So the core thing that lies within Airthing technology is literally, if you think about the story of Kodak film and how we went from analog films to digital cameras, it's literally the same kind of journey. I have an Airthings Wave Plus behind me here, and one of the 7 sensors in here is what you see on the photo, which is similar as the radon puck, but now digitalized. And instead of a film that has to go to a laboratory to be developed, we have a sensor at the bottom there that captures continuously the alpha particles and be able to and can calculate the radon concentration in there, and then also capture the variations over time. But it still doesn't. We still need to take into account that the concentration will evolve throughout the year, and how do we then dynamically control our building? So historically, what's been done is that you do a very short electronic measurement period, so maybe like a week, up to a week, 2 weeks, and you have a very small measurement window that doesn't give you that feedback to really optimize your mitigations. But let me illustrate the challenge around this with an example, and a very good example of this from Norway. So this happy chap to the right here is Geir, and he's a building operator on the west coast of Norway. And I love being out and seeing actually the realities of what it is to run and operate a building, because even though I'm very focused on IoT and sensors and indoor air quality, the reality for some people, the people out there operating a building, is that you have a lot of other concerns to deal with. So you want your systems to be intuitive and accessible, and not cause more headaches than they're worth. So Geir is responsible for about 100,000 square meters of property on the west coast of Norway through a company called Frydenberg, quite a big property developer. And they had identified a couple of buildings that had challenges around radon gas. And they had done the traditional measurements where they did a long-term measurement with a trace film or a radon puck, and then followed up with a short period of electronic hourly measurements, and say, okay, here we need to do some actions. But that's the amount of insight they had to do those mitigations. So they put in a very, very defensive, very conservative solution to this, and they extend the ventilation hours, and they say, okay, this is probably resolving the problem, but they didn't have any insight to really optimize and make sure that they're not overspending on energy, that they're not overusing their ventilation system. So what we were thinking as a solution to this, okay, well, how can we take into account data from all of this period? I'm going to sit down now slowly and maybe tilt the camera down so you can still see me. How do we help Geir get the insights from his data that he can actually optimize the ventilation? So let me go in quickly here to the Airthings dashboard. And I did check with Geir beforehand if it was okay if I showed his account. So this is access to all of the sensors that they have installed on pretty much all their buildings in Bergen. So they have full remote monitoring. And if I go in now, and I'm going to show you something that we haven't even released yet, but something that Geir has been testing out, and he made these changes, I think, about 2 weeks ago. So what I'm showing you now, what I want to do is gather the data, the measurements that they've been doing for the last 6 months, and create an insight to really understand how the radon fluctuates within this space over a longer time period. So not just a point in time measurement, but really understanding how this building is dynamically changing. Very importantly, I put in the opening hours of the space, because we need to take that into account. When are people actually in the building, and when is there a danger for them being exposed? And I select a specific. So this is my building, and I'm selecting a specific room in this building, or one sensor. The great thing, they have been measuring since October last year. So let's just do a long time period here. And the benefit of having data in the cloud and having it easily accessible is that we can do this kind of data crunching in the cloud and come up with one quick overview for a guide. So here I have the long-term measurement, and I see that so this would be equivalent to what the radon POC would produce, and it shows that the concentration are over the action level, so 117 becquerel per cubic. However, inside opening hours, when people are actually in the building, it's well below the normal levels. And I can see that as well on this weekly graph, which is a representation of how the concentration fluctuates throughout a typical week. And what I noticed, when the ventilation system is not running, we're reaching quite a few hundred becquerels. So this equivalent in the US, for our US listeners, it'd probably be around 8, 9, 10 picocurie. But very quickly, once the ventilation turns on at 4 a.m., we're dropping down to well below the action level. So actually looking at this graph and seeing how that we're managing to keep the air quality healthy during working hours, I could recommend to Guide that he can save a couple of hours every day on ventilation, both before and after work. And I also noticed that they have there's clearly ventilation running in the weekend despite people not being in the buildings. And I talked to Guide about this, and this again was this blindly trying to optimize without getting any feedback. So what they thought is, okay, let's just try and flush out the buildings during the weekend so it's less of a problem on Monday morning to clear out the building. But what we can see is that we're very quickly reaching up to a certain saturation point. So the Saturday ventilation might not have much to do, have much effect. So I could probably recommend, based on this, Guide could see that he doesn't need to ventilate on Saturday and perhaps cut down on Sunday and instead maybe start the ventilation an hour earlier. So already from this, I think that he made some changes last week. He reduced his mitigations by, I think it's 12 hours now. But he's estimated that he can get his savings in energy to pay the sensors within 3 to 4 months. I think that's a great illustration of how we could use this. And I think, but automatic, that's a very manual process. And I think the opportunity is also to automate it in some sense. And here I have a picture from Niagara, which is a building automation system, the schedule update. And I think my ambition would be to make this available so we can dynamically adapt to the ideal ventilation schedule as the building evolves. And this is something we've already been looking into, and we've done some API tests with it.
Martin, I know that you're very proud of your vest today, but I also like to see your face.
Oh yeah, sorry.
Wow,
my mouth is getting dry, and I think that was a good time for you to interrupt me, Tommy, because I see the clock is ticking away.
I know that you're showing off your cool mic, but I have to say, Martin, I think this is awesome. I'm always very interesting when what you and your team up, new features that are popping up all the time. And I really love one fact that the building is even getting smarter by night, because this is new features that is just popping up over there when you push the button, right?
And I think that's the beauty of these property technologies, is that we can do over-the-air updates, and the hardware investments, technology you do in your buildings are continuously being improved. But Tommy, let's go on to probably the part of our session today that I've really been looking forward to, which is sharing some of our thoughts from our trips. Yes. I know both of us, even though we work in a technology company based in Norway, we do have global ambitions, and we try and keep our eyes open to what's happening around the world.
For sure. We only have 10 minutes left. I think both me and you stole a bit more time than we had. So we have to save all of the questions after the webinar. We will try to answer everything that is coming in. But just one...
So please submit them to Antoinette. Good idea.
Yes, please do that. And also, Martin, you just have to answer on one quick question that I got from Germany, UK, and US now. When is the new feature for radon available for existing Airthings users?
So we're currently beta testing with quite a few customers. So I hope by the end of April we can do that.
Cool.
But sorry.
Yeah. So that's perfect. So all of the existing Airthings customer will have this month. Perfect. So let's go on. Start sharing our travels around the world, and also, Martin, you need to share your mic and how you made that yourself on LinkedIn afterwards. Okay.
I will do. Perfect. So I think what's an important thing that we're seeing, and what we're going to share from a few of our trips now, about the learnings that we've done around the world and that we take into our product development in Airthings. I think one of the first things that we notice is that air quality is definitely growing in awareness around the world.
Yeah, and this was something that was popping up for us in London, in Berlin, and we really see that this is a very important for all of the people out there. And this was something that we also wanted to learn more about, and we also have some interaction with this in our dashboard, right, Martin?
Yeah, so what you're seeing on the photo there is the first thing that hit us when we came to London. It's quite a few months ago now, and it's an outdoor air quality monitoring station. And actually in Norway now, all municipalities are required to do outdoor air monitoring and risk assessments. And what's interesting about these stations is that the data is also made available and we can access them easily through APIs. I know a great platform called Breezometer, which collates all of this data from around the world and makes it available to an API that we could, in theory, take into our building automation system if you want to adapt the running of a building according to the outdoor air quality.
And probably what's neglected here is the indoor air quality, right? Because the outside air will come in eventually. And I think that this really sets the pressure on buildings and how we can monitor and the performance that they are doing. And that takes me to this picture, Martin. US, what did you feel when we landed here in Oakland?
In Oakland, I think that's where we realized that it's not only outdoor air quality, which is high on the agenda, but also indoor air quality. The first thing that hit us as we landed in California was a huge plant wall on the back of the terminal and a lot of information on posters really bragging about or talking about how the quality of the indoor air is within this airport and how it's being filtered and taken care of.
And when we checked into the hotel, it was the same feeling, right? And we got asked to upgrade to our pure rooms, and we wanted to look more into that, but of course that was sold out. And you started to read every brochure about it, and we also had to visit a few more hotels to look at it, right?
This is a fascinating concept that we noticed in the US. So instead of luxury upgrading your hotel, you get the option to improve your indoor air quality or indoor environment within hotels. And we initially thought that this was just something that Marriott Hotels had, but it turns out that this is an offering that is across several hotel chains in the US these days, and offered by a third-party company here shown from the website, the Pure Experience. And what they offer the hotels is the certification process, the standard, and the guidelines in terms of bed linen. The furniture has to be low VOC emitting. The cleaning chemicals have to be certified and make sure that they have very low amounts of volatile organic compounds that could damage the air. And of course, there's sensor technology to monitor and make sure that the air quality is maintained to a satisfactory level.
And we got the same confirmation when we went to the first office that we visited there, OSI. They were also extremely concerned about indoor air quality and really up to date.
Yeah, so we came along to observe the installation of indoor air quality monitoring at OSI, which is a large software development company for industrial customers. And I know some of the oil companies here in Norway also use them. Yeah, and it was a fascinating building.
Yeah, it was a big living lab. They had so much sensors there. And maybe the coolest thing was that every window had its own IP.
Yeah. It's the first time I've seen it, but actually as an energy saving measure, all of these windows were accessible through the building automation system. So you could electrochemically change the shading of the glass to reduce the heat radiation from the Californian sun. So brilliant technology.
Yeah, and in terms of air quality, there was also screens everywhere showing values, showing indoor air quality. And when we were installing sensors, everybody was so curious and asking, when can we see the value? Where will you display it? And which screen will it come to?
Showing it, and I think that's showing a general trend that people are thinking much more about air quality and thinking about how it should be within their buildings. But of course, Tommy, as always, when visiting buildings with you, the highlight is when we get invited up to see the technical plant and the ventilation units. So we were invited up to after a little bit of asking and begging, we were invited up to check out. And one of the things I learned, which is an interesting observation, is that there is a key differentiation between European and at least Northern European and American HVAC principles. So in Norway, there's 100% fresh air coming into, or outside air coming into as a ventilation principle. But in the US, as an energy saving principle, there tends to be a lot of recycling of the air within the building. So I think in what we see here is about more than 80% of the air that's brought through the system is recycled, which puts the different demands on the filtration and on the ventilation system.
Yeah, and they also had much smaller filters than we were used to, Martin. And they used this really cool technology. There you have it, where you have some electrical fences that will actually make the particle to collide and also scrub it.
Yeah, it's this is a category of products that we're not familiar with in Europe, and we're very curious about to hear more about. But they're called air scrubbers, and this is one particularly innovative solution to this. It's very, you see the thin films of nearly chicken wire in the middle there, which is meant to make the particles that I was talking about earlier, the very, very small ones, bigger by accelerating them and colliding them. But it also has an impact on other indoor air pollutants.
Yeah, and that was also the reason that we installed our sensor. So when we came home, they actually turned off the solution, and they could actually see that the CO2 was rising when the solution was not on. So it was actually they also saw all of the facts and all of the insight on all of the data for the solution. So it's pretty cool.
So if anyone's listening and has more insights to share with us, we'd love to learn more about this technology.
For sure.
I think it became very apparent to us why there was this big general awareness about air quality, both indoor and outdoor in California. And it was due to the wildfires that now become an annual occurrence, carpeting nearly the whole state in a blanket of smog and pollutants in the air.
Yeah, and these office buildings was, when we talked to people in them, they talked about it as a shelter against bad outdoor air. And when they had a wildfire, they felt safer at work than home and outside of the home because of the technology. So that's something that we haven't seen before. So that was very interesting.
But I think it's an important lesson for building owners and operators around the world is that, and the pressure of ensuring that our buildings are safe harbors for potentially lethal and damaging outdoor air pollutants, particularly now that we're getting a bigger awareness and understanding of how important the air we breathe has on our health and cognitive abilities. Yeah. So really, you need to ensure that you have the technology in place to make sure that you're monitoring and can provide that safety and breath of fresh air for the occupants. Okay, this was the highlight and probably my favorite bit of this trip to the US, and that was our visit to the Life Chiropractic College outside San Francisco. And really the visit here was a reminder and inspiration for me to see how if you get insights or data about your building, and if you appreciate your building as a living dynamic thing, it really can evoke creativity and find and solution oriented, even if you don't have the investment budget that you'd love to have to get the optimal conditions.
And they also had our own committee just for indoor air quality. And they had so high knowledge of CO2 and how it affects us cognitively. And there was also one big star, Martin, Michael Baldwin.
Yeah, so Michael Baldwin was the creative inventor and building operator or operations manager in the facilities here. And he had been set some very stringent challenges by this board committee on indoor air quality in terms of what levels of indoor air pollutants he can have in the building. So they have a very active school day. Here you see them in a learning environment. So it was quite a challenge for Michael to ensure that they had good air quality.
Yeah, and as you said, he didn't have the budget, so he had to find where the problems were, how they could solve it, and he tried so many creative solutions like plants to eat up CO2, to air the rooms between classes, and also he made the coolest invention that we haven't seen before. And I think that you also have a video of that, Martin.
This is where the creativity, once you get the levels and you get the insight and you have the sensors in place, you can do experiments and find out what's the best mitigation actions that I can afford and we can do in this case. So here we're seeing Michael in the background with his algae air scrubber. So what he's done is found a particular breed of algae that are very efficient at sequestering CO2 from the air. He's reused a water bottle in the bottom there and added a growth light and a fan to encourage the circulation of air. And this really, he was able to measure the effect that this had in each classroom on the CO2. And after he saw that this was the most successful impact he could make, he spread it now into every classroom and also into the common areas.
Yeah, and this really shows the power of just having one sensor in a room to have the insight, to be creative. And then we also talked to Michael afterwards, and now they could actually see which ventilation system they had to change, and they could actually make a plan and how much it would cost and how much they will save. And I think it's just a fantastic example of how they could actually be data-driven in investment as well.
Exactly. We did also get into downtown San Francisco, where all the well-known technology companies are based. And I'm quite fortunate to have a few colleagues working in some of these tech companies. So we were able to go and visit. We had lunch at the Uber offices. We visited the LinkedIn office. Tommy was particularly a big fan of their platform. And we also went to the Salesforce offices. And what I noticed in all of these places is how they're actively using the indoor environment as a competitive element in a very competitive competition to attract good talent.
Yeah, and we also really wanted to go deeper into the indoor air quality standards, such as Well and Reset. And I think, Martin, for seeing in Norway big players like CBRE, Skanska, that is actually building the first building in Norway now with Well standard, that's also something that we need to look at, how we can build buildings for tenants and well-being and not just for energy.
Yeah, and you saw that already on the entrances, like there were all the common areas entrances were plastered with advertisement about these certifications. But what I'm particularly curious about, as you mentioned, are these new indoor environment, indoor air quality focused certifications that are particularly gaining traction in the US, but we're seeing a lot of them coming through to Europe and some also stemming from Europe, like Air Rated. And they're, as I see them, they're trying to reestablish this balance between the energy savings and the envelope of the building, and instead focusing on the people within the buildings and the indoor environment. And I'm particularly excited about Well, for example, and they're forcing us to think wider about what it is to measure within the building and what we need to measure. It's no longer sufficient with the comfort parameters like temperature and humidity, but in the certifications, they're mentioning continuous monitoring of PM or dust particles, CO2, formaldehyde, carbon monoxide, VOCs, nitrogen dioxide, ozone. So much broader spectrum of parameters that we haven't had the same awareness around. Probably my favorite big and a shift is that these measurements can't be hiding within your building automation system. They're no longer, they should be made accessible to the people within the building as well. And here I've taken a screenshot from the Well standard. This is an extra point you can get for creating air quality awareness in the building and making this data displayable. It's a bit similar to what we saw at the Uber offices and at the OSI offices, Tommy.
Yeah, and I'm really looking forward for this step, Martin. And I know there is a lot of more exciting stuff that we can't share yet. And also, as you mentioned, there will probably be new sensors in the futures, and that is focusing on Well and Reset. But Martin, we are 2 minutes over the time. So everybody, thank you so much for seeing everything. And everybody that sticked around till now will be, I think we are doing that on Friday as well. Then it will
announce it on Friday, but Antoinette is doing the draw as we speak.
Yes. Who's winning excited. Will be announced on Friday. And please ask us questions, send us mail or LinkedIn or call us, whatever, and or also questions in the WebEx platform. So
maybe about the calling, take into account that we're in Norway, so take into account the time zone differences. That might be a good thing. But yes, okay. Thank you very much for your time today, and I hope you enjoyed the webinar.
Bye. Okay, see you soon, Martin. Bye.
Bye, Tommy.